This is the recording for topic 13-4, zeros and negative exponents. Our objective for today is I can simplify expressions involving zero and negative exponents. For this topic, you will need your topics out, and you should be working on the bell work problem that's given, as well as you will need a calculator. Our bell work problem says, sorry about that, I had to make it so we could actually see it. We have Martha has $180. She needs a total of $2,000 to start an account. She earns $60 per day working, of which she saves $50. Which equation can be used to determine the number of days D she needs to reach her goal of $2,000? At this time, please pause the video and come up with your solution. Okay, now let's figure out how we can get the solution. We know that her total is going to be, her goal is $2,000. That's given. Every single one of the equations has it equal to $2,000. So now let's look back at what it start off with. She has $180. That is her beginning amount. Because she begins with $180, it's positive. That means we can get rid of B because this has a minus 180 or negative 180. So B is out and also D is out. Next, we have that she needs a total of $2,000. We already have that in our equation. She earns $60 per day, of which she only saves 50. So that's the key word, is that she's only saving 50. And if we're trying to determine the number of days she needs in order to reach that 2,000, I'm only saving 50, and so therefore C is the correct answer and not A. So our topic, let's get started. We are talking about exponents that are zero, that is zero. So our rule is that for every non-zero number B is our base, and this is a non-zero number, any non-zero number raised to the 0 power is going to be equal to 1. So our first example, we have 5. 5 is not equal to 0, but 5 is raised to the 0 power, so it's equal to 1. Our next example, we have negative 2. Negative 2 is being raised to the 0 power. It's going to be equal to 1. I have 34.693. That is being raised to the 0 power. It must be equal to 1. 1/4 being raised to the 0 power, and now is equal to 1. The only one we do not know is if we say 0 to the 0 power. We don't know because that is not our rule. Our rule is any non-zero number. So that number can be anything, a positive, a negative, a fraction, a decimal. It can also be a variable that represents a non-zero number, and then it is equal to 1. So we know B is not equal to 0. B has to be some other number. The other thing that we'll be dealing with today are negative exponents. When we're talking about negative exponents, we see our base is being raised to a negative exponent. So when you see a negative exponent, I want you to think of your number. Just think, we're going to be dealing with fractions in a sense. And so if you have a negative exponent on top in the numerator, then to make that exponent positive, we move it on down to the denominator. And now our exponent becomes positive. Notice the number itself for our base, the 6, stays a 6. It does not change. The only thing that changes is the location of the number raised to the exponent. So now we can simplify this. This is 1 over 6 to the 4th power. We're going to stamp it out like we've done before. That means I'm doing 6 times 6 times 6 times 6. Then that was going to equal 1 over 6 times 6 times 6 times 6 is 1,296. So our next example, we have x to the raised to the negative 2 power. Again, I see I have a negative exponent, so I want it to look like a fraction. Let's make my problem look like a fraction by putting it over 1. Then, since I have a negative, I'm going to move it on down. So this becomes still the same base of x, but now the exponent's positive, and the 1 now is on top. My last example, notice I already have it looking like a fraction, or I notice I have I have a base raised to a negative number, so my 2 is raised to a negative exponent. So now, since I started at the bottom, we're now going to move to the top. So the 2 goes now on top. Notice the 2 doesn't change, it's still a 2, but the exponent is now positive. And I put it over 1. So this becomes 2 times 2 times 2. We stamped it out 3 times, and that is 8. So now let's do this. Our first problem, we have 3 to the negative 4. I see a negative exponent, so I'm going to write it like a fraction over 1. The negative initially was on top, the negative exponent, so now we move the base, the same number, exponent becomes positive, and the 1 comes on top. A lot of times my students think, hey, I'm just going to flip that whole thing. What's on top comes bottom, what's bottom now becomes top. We now have 1, and then we'll stamp out the 3s. There's 1, 2, 3, 4 of them. So 3 times 3 times 3 times 3, this is where your calculator comes in handy, is 81. Our next problem, we have negative 7 raised to the 0 power. I see something raised to the 0 power. This negative 7 is not 0 itself, so that has to be 1. Our next example, we have 4 raised to the negative 3. Again, it's the exponent. That's a negative exponent, so I'm going to put the whole thing over 1. And now the 4 goes on bottom, and the exponent becomes positive. It is now 4 to the positive 3. So I'm going to stamp the 4 out 3 times. 1, 2, 3. And so the 4 times 4 times 4, this is 64. We have 1 over 64. There's our final answer. Let's keep doing some more examples. We have 7 to the negative 1. Again, I see the negative, so I know I'm going to have to do some moving. It was on top, so now it moves to the bottom. The 7 stays a 7, but the negative 1 now becomes a positive 1. And so this becomes 1/7. Number 11, again, I see a negative exponent, so I'm going to write this over 1. Now my 3 goes in the bottom, and the exponent becomes positive. So I have 1 over 3 times 3, and 3 times 3 is 9. Number 12 is our last one, in which we only have one term that we're dealing with. So again, I notice I have a 3 raised to negative 3. I need that exponent to be positive, so I started on the bottom. We're going to move it to the top. The 3 stays the same, the base 3, but now my exponent becomes a positive 3, and now I have the 1 on the bottom. So we have top 3 times 3 times 3. I stamped it out 3 times thanks to the exponent. 3 times 3 times 3 is 27. 27 divided by 1 is just 27. Started with number 13. Notice you have more than one term. We have a 4, we have x to the negative 3rd power, and then y. When you have more than one term, it is a good idea to write the exponents of all the terms so that you can figure out which one is the negative exponent. What I mean by that, if you do not see an exponent, it's an always understood 1. So 4 to the 1 power is still 4. We have x to the negative 3, and then y doesn't have an exponent, so we'll put a 1 there. Now all these terms are being multiplied, but I want us to find the one that has the exponent that's negative. That is, I'm going to circle it. That is my x to the negative 3 power. That is the only one that's negative. Since I do have a negative, though, I'm going to draw my line and put a 1 underneath, because this one term that has a negative exponent will now move to the bottom. So I still have x, but now the exponent becomes a positive 3. What's on top? I still have my 4 to the 1 power and my y to the 1 power. They did not have negative exponents, so they did not move. This is my final answer. I cannot simplify any further. So my final answer is 4 times y. All of that is over x to the positive 3. Let's look at number 14. I only have one term. Now one term is in the denominator. It has a negative exponent, so that means I need to move it in order to make that exponent positive. To make it positive, I move it to the top. The negative 4 becomes a positive 4. My 1 is now on bottom. Well, anything divided by 1 is just what it is, so I have a to the 4th power is my final answer. Let's look at number 15. I have 11 times m to the negative 5. 11 doesn't have an exponent, so I'm going to put a 1. So that helps me see that m is the only thing that is being raised to my negative exponent of negative 5. So I'll put my line and put a 1 there. I don't need to write equal again. So now the 11 doesn't have a negative exponent, it has a positive 1. It stays on top. but the m is raised to -5, so it moves to the bottom and the 5 becomes positive. My final answer is y m to the 5th. Sorry, y divided by m to the 5th. Second number 16, I have a 7. It doesn't have an exponent, so I'm going to put a 1. I have s to the -4. I see my s is being raised to negative power, so I'm going to circle it. And t is being squared. It is not negative, so I'm going to leave it alone. Since I do have a negative exponent, I'm going to go ahead and write this as a fraction, putting it over 1. So now look, 7 is raised to a positive 1. It doesn't move. S is raised to -4. That means it needs to move on down. So the s comes down, stays in s, but the exponent now becomes positive. Last, I have a t. It's being raised to a positive 2, so it doesn't move. It stays up on top. My answer is 7t squared, all of that over s to the 4th power. Looking at 17, the 2 doesn't have an exponent, so I'm going to put it to the 1 power. But I do see my a is being raised to the -3 power. I'm going to circle it because that tells me I need to move it. The 2 is raised to a positive 1. It doesn't move. A to the -3, it has a negative exponent. I need to move it to the top. So I get a, and now it's raised to a positive 3. What's on bottom? I don't have any numbers there shown, but hey, I can say there's an understood 1. So now when I simplify, I don't need to write that 1. I just say 2a cubed. Notice the a is the only one being raised to the 3rd power now. 18, I have 2 terms. I have an n to the -5th and v squared. So I'm going to circle my term that has the negative exponent. That's my n. Write my line so I know I have some kind of fraction. Now my n is being raised to the negative. It was on top. We're going to move it to the bottom. It becomes n now to the positive 5. I look at my v. It already has a positive, so I do not move it. It stays in its location. So now I have nothing on top. There's always an understood 1 there. So my final answer is 1 over n to the 5th v squared, that quantity. Now let's combine some things. Not only do we have negative exponents, we have negative numbers, we also have parentheses. So let's start with our parentheses. Well, let's start with, I know I have negative exponents, but let's also start with, I have some terms that don't have exponents. I'm going to go ahead and write a 1 where the terms are that don't have exponents. So the 4 is being raised to the 1 power, as well as the -2 is being raised to the 1 power. I do that so I can show that, hey, this t to the -3, t is the only one being raised to the negative power. So now we have exponents on the outside. We also have negative exponents. We have choices. My students have told me they would like to get rid of the negative exponent first. So let's go inside this parenthesis and see. We have t that's being raised to the -3 power. Hey, that tells me, let me go ahead and draw my line so I know I'm going to be dealing with fractions. So I'm dealing with my fractions. The 4 is to a positive 1. It stays there. My t squared, that t, the 2 is positive, so it stays on top. Now in parentheses, I'm going to keep my parenthesis. I now have a -2. Hey, it's still on top because it has a positive 1. But what does move is my t to the -3. It's going to move to the bottom. And now that 3 becomes a positive 3. This is in parentheses, and it is raised to the 3rd power. You got to love the multiplication because it means I can rearrange things. Right? So I have an exponent outside parentheses. This means I need to stamp out that exponent, or stamp out that parenthesis, I should say. So I got a -2 t cubed. That's 1 time. -2 t cubed. That's 2 times. And a -2 t cubed. That's 3 times that I'm stamping it out because of the 3 that's on the outside. Now I can do these problems. What we've done in the past, we're going to do again. We're going to rewrite it, put in our numbers first, or a constant. So I got a 4. Here's my 4. I have a -2. Notice all these parentheses. I no longer have exponents on the outside, so I can just multiplication. So this becomes a -2 from the first parenthesis times a -2 from the second parenthesis times a -2 from the last parenthesis. Those are my numbers. Now we're going to put our t's together. At the top, I have t squared, so I'm going to stamp out two t's, 1, 2 for my 2t squared. Then in the parenthesis, I got t cubed, so it's 1, 2, 3. I'm stamping out 3 of them. Second parenthesis, t cubed, so 1, 2, 3, yet again. In the last parenthesis, I got t cubed, so 1, 2, 3. Now I can cancel things on top and bottom. We cancel out. And now we simplify. In the top, I've got negative 4, sorry, it's a positive 4 times a negative 2 times a negative 2 times a negative 2. And this is where your calculator can come in handy. Pull it up. And we'll type in 4 times negative 2 times negative 2. Notice I'm using the parentheses, so it looks just like what I wrote down. This gives me a negative 32, so I have on top a negative 32. On bottom, I have t's. And now we're going to work backwards from the stamping. So we got 1, 2, 3, 4, 5, 6, 7 t's. So this is t to the 7th power. So my final answer is negative 2 over t to the 7th power. Okay, let's look at number 20. Anything that doesn't have an exponent, put a 1. So we have 2 to the 1 power, m to the 1 power, n to the 1 power. In my first parenthesis, I have 3 to the 1 power, and oh, I see a negative. So it tells me I need to rewrite this. And the way I'm going to rewrite it, let's just start off. 2mn, I'm going to keep that, not stamping anything out. The one thing I want to work on now is the parenthesis, 3. But my m cubed, or negative 3, now becomes m on the bottom, moves to the bottom, still in the parenthesis, but now the exponent becomes positive, and we still have it raised to the 2nd power. Now we get to, let's get rid of these parentheses. I have exponents on the outside, so this tells me how many times to stamp out the parenthesis. So I'm going to stamp out 2m to the n, or 2mn, that's 1 time, and 2mn, that's 2 times. And now the 3 over m cubed, I stamped that out 2 times also. So 3 over m cubed, that's 1 time. 3 over m cubed, that's 2 times. We've taken care of the parenthesis on the outside. Now let's rewrite it. So our numbers come first. We have 2 on top from the first parenthesis times 2 from the second parenthesis. Go ahead and put in parentheses. Times the 3 from the parenthesis and another 3. Okay, now I want to look at my variables. So let's start with m. So I got an m from the first parenthesis, an m from the second parenthesis. Then on the bottom, I have from my first parenthesis, I got m cubed, so that's 1, 2, 3. I'm going to go ahead and stamp them out. And then another m cubed, so it's 3 more. 1, 2, 3. Stamp it out. And then last but not least, I still have some n's. So I have an n from the first parenthesis and an n from the second parenthesis. Now we get to multiply using the calculator. 2 times 2 times 3 times 3 gives me a total of 36. So I have 36 in the numerator. M's, let's cancel top and bottom. Top and bottom. I see I have some m's on the bottom. So there's 1, 2, 3, 4 m's. So we'll do m to the 4th power. And then I have n's on top. So there's 2 of them. It's n squared. So my answer is 36 n squared over m to the 4th. So our last one, I see a negative 24. That means its exponent is 1. It doesn't have 1. I see a to the negative 3rd, so I'm going to circle it because it's a negative exponent. That reminds me, hey, I need to move it. We have b to the 4th. In the bottom, we have 6. It doesn't have an exponent, so I'm going to put it to the 1 power. A to the 5th, b to the 2nd, and c to the 0. So a couple of things. Let's go ahead and rewrite a couple of things. One, I know that, hey, I got a negative exponent. That means I need to move it to the bottom. So the negative 24 stays on top. It still has a b to the 4th on top. We still have a 6 to the 1. We now are going to have an a to the 5th. And now I'm going to move my other a. And it is now to a positive 3. Move it to the bottom. We have a b squared. and then c to the 0 power. Now we can rewrite, put our numbers together. Negative 24 on top, 6 is on bottom. Take care of the numbers. Now I'm going to go alphabetically. So I see some A's. They're all on the bottom. A to the 5th, we're going to stamp out 5 times. 1, 2, 3, 4, 5. That's my A to the 5th, but now I also have A to the 3rd that's on bottom. So 1, 2, 3. Now we can do our B's together. B to the 4th, stamp it out 4 times. 1, 2, 3, 4. B squared, we'll stamp it out twice. B, 1, 2, it's on the bottom. And last but not least, we have c to the 0 power. Remember, anything raised to the 0 power, that equals 1. So I'm going to go ahead and put a 1. And actually, since it's now a number, let me move that 1 over here next to the 6. So we'll say times 1. So now we're going to use our calculator. This negative 24 divided by 6. And I'm just going to say 6 because negative 6 times, or 6 times 1 is just 6. So negative 24 divided by 6 gives us a negative 4. It's a whole number. That means it goes in the numerator. So we've taken care of the numbers. Let's look at the letters. All the A's are in the denominator. So I'm going to have A in the denominator. Let's count them up. We got 1, 2, 3, 4, 5, 6, 7, 8. And in the B's, I got top and bottom, top and bottom. I'm left with 2 B's on top, so B squared. So my final answer is negative 4 B squared A to the 8th. This concludes our topic on simplifying expressions involving 0 and negative exponents.